So V engines are the type of engine where two connecting rods they run a common shaft, or we can also say that in this the cylinders are grouped together at certain angle in such a way that they share a common shaft. A common crank. And the common angles at which the cylinders they are grouped, they are usually 45 degrees, 60 degree and 90 degree. And these are quite different from the inline engines where the cylinders are placed in the straight line, because by placing the cylinders at certain angle or by grouping them, we are making the system actually compact. We are reducing its dimensions and we are also reducing the weight because one crank is being shared by both the connecting rods. Now we'll do the analysis of the primary and the secondary forces. That means the primary and secondary unbalanced forces because of the reciprocating parts in case of a V engine. If we look at the diagram properly, we'll see that there is a common crank OA, and this crank is running, or it is connected to two connecting rods AB1 and AB2, and at the end of these two connecting rods there are two reciprocating parts or pistons which are denoted by B1 and B2. So let this be system 1 and let this be system 2, and we've arranged the system in such a way that the masses, the reciprocating masses, are same for both the bodies, and the mass at the crank pin, that means at A, it is denoted by capital M, and the crank is OA, which is common. Now we know that the unbalanced forces produced because of the reciprocating parts, it has got two factors, the primary and the secondary forces. So primary forces basically mr omega square cos theta, which we have already derived in earlier videos. So we'll see the primary force along the line of stroke. So if we say that a single slider crank mechanism, this is the slider, it will help you to visualize how the system is working, and OA, right? So the primary force was acting along the line of action. If this is going this way, the inertia force, the unbalanced force, is acting in this direction, right? So the primary, if this angle is theta, the primary force is mr omega square cos theta. So for the system 1, what is the angle which the crank makes with the line of stroke? If this angle whole is theta, I mean the angle which the crank is making with the x-axis, this angle is theta, and the angle between both the connecting rods, this is alpha and alpha, the angle of connecting rods, and the angle of crank with x-axis is theta. So the primary force along the line of stroke, this line, it becomes what? Mr omega square cos, this angle is theta minus alpha. So it is something like this, that crank is this angle is theta. So for the line of stroke, it becomes theta minus alpha, right? So the primary force along the x-axis will be what? The cos factor of this angle alpha if the primary force is acting along this line, and if this angle is alpha, the force, the primary force because of body 1 or because of the cylinder 1 will be mr omega square cos theta minus alpha. Cos alpha, this is the cos factor, right? Now similarly, if we talk about the slider crank mechanism, or if we talk about the second connecting rod, the primary force along the line of axis, that means this is mr omega square cos. Now see, what is the angle crank is making with the, at this particular stage, it is making an angle, this angle. If this is the crank, you see, if this is the crank, it is making the angle theta plus alpha. This angle is alpha and the whole angle crank is theta. So if you look at the triangle OAB2, so the angle, whole angle which AOB2 is, it's theta plus alpha, right? And if this is the force which is acting here, so the force, the primary force along the x-axis will be its cos factor, so it will be mr omega square cos theta plus alpha into cos alpha. That means there are two forces which are acting along the x-axis, one because of this reciprocating part 1 and because of the reciprocating part 2. So the total force, it will get added up, right? So we'll add this force and this force, right? So we can take mr omega square cos alpha common, and we'll be left with what? Cos theta minus alpha and cos theta plus alpha. So we expand these trigonometric expansions. It will be cos theta minus alpha is cos theta cos alpha plus sin theta sin alpha plus cos theta plus alpha is cos theta cos alpha minus sin theta sin alpha, right? So these two factors, this is positive, this is negative, they get cancelled out. So what we are left with, 2 mr omega square cos alpha and cos theta cos alpha. So it becomes cos square alpha and cos theta. Now similarly, if we do it for the z-axis, if this is the primary force along the line of stroke, for z-axis it will be mr omega square cos theta minus alpha. This, it will be sin alpha, and for this, for the reciprocating part 2, if the force is acting along the line of action in this direction, it will be mr omega square cos theta plus alpha sin alpha. Now you see along the x-axis or along the vertical axis, the both forces or the components of primary forces is in opposite direction. So when we find the total primary force along z-axis, we actually subtract them. So it becomes mr omega square cos theta minus alpha sin alpha minus mr omega square cos theta plus alpha sin alpha. Because they are the vertical components, both of them are sin alpha, and we have already assumed that the angle which the line of stroke of both the system makes with the x-axis is alpha. That is common for both the systems. So it becomes mr omega square sin alpha. What we are left with is cos theta minus alpha minus cos theta plus alpha. So if we expand these trigonometric equations, it becomes cos theta cos alpha plus sin theta sin alpha minus cos theta cos alpha plus sin theta sin alpha. So these two, they get cancelled out, and we are left with 2mr omega square. See, sin square alpha, because one sin alpha was outside the bracket and one is we are getting from inside the bracket. So it becomes sin square alpha sin theta. So what we have found out, we have found out the unbalanced primary force along the x-axis and the z-axis. So what will be the resultant? It will be under root x square plus x component plus y square component, or the z square component we are taking here. So the two resultants, we like under root and square of these two components, and whatever is the common factor we are getting, which is 2mr omega square, we take it out from the root, and this is the resultant that we are getting in the system. So we are getting the resultant unbalanced force because of these two unbalanced primary forces along the x and the z axis. And if we want to find the angle, what we do, we divide both the terms. So 2mr omega square, it gets cancelled out. We are left with this factor, which is sin square alpha sin theta upon cos square alpha cos theta. So when we place the values, we also get the angle beta, which is the angle of this resultant unbalanced primary force. Now to find the maximum condition for the resultant force, that means the condition when the resultant force is maximum, what we do? We actually differentiate the variable factors and we equate them equal to 0. So differentiation of cos, so this value cos square alpha cos theta whole square plus sin square alpha sin theta whole square, it should be maximum. So we differentiate it and we get this value, and the resultant that we get is when theta is equal to 0, in that case the resultant force, it comes out to be maximum. Right, we have talked about the primary forces, and there are also the secondary forces which are acting, the secondary unbalanced force which is being created or which is acting on the reciprocating parts. And we know the secondary force is mr omega square cos 2 theta upon omega square cos 2 theta upon n for the system where n is what? It is the ratio of L upon R, or the length of connecting rod upon the length of the crank or radius of the crank. So similarly, like we did for the primary forces, we'll do it for the secondary forces. So secondary force along the line of stroke for the system 1, it is mr omega square upon n cos twice of what angle? This angle, which is theta minus alpha, right? So the secondary force along the line of this x-axis, it will be mr omega square upon n cos 2 theta minus alpha cos alpha, because this angle is what? It is alpha. So we'll take the cos factor. Similarly, when we do it for the second connecting rod or the second reciprocating body, same, it is mr omega square upon n cos 2 this angle, which is theta plus alpha, right? This angle. So this is theta plus alpha, and along the x-axis it becomes the cos factor, which is cos alpha. So the total total secondary force along the x-axis will be addition of these two, right? And we expand this 2 cos 2 theta minus alpha and cos 2 theta plus alpha. This sign factor, it gets cancelled out, and we get this value, which is 2 mr omega square upon n cos alpha cos 2 theta cos 2 alpha, right? And when, like we did for the primary forces, now we have to find the value along the z-axis. Only then can we find the resultant secondary force. So for z-axis, the same forces, this force, the vertical component, which is sine alpha, and the sine alpha. Now because the secondary force, this sine alpha, because of 1 reciprocating passes in this direction, and for 2 it is in this direction, so they get subtracted, right? So it becomes mr omega square upon n cos 2 theta minus alpha sine alpha minus mr omega square upon n cos 2 theta plus alpha sine alpha. Now we take the common factors out, which is mr omega square upon n, and we expand this trigonometric expansion, which is cos 2 theta minus alpha and cos 2 theta plus alpha. So these factors being like common in opposite signs, they get cancelled out, and what we are left with is this 2 mr omega square upon n sine alpha sine 2 theta sine 2 alpha, right? This is sine 2 theta. So what will be the resultant? It will be the x and the y component. So we'll find the resultant of the secondary forces, which is 2 mr omega square upon n under root cos alpha cos 2 theta cos 2 alpha whole square plus sin alpha sin 2 theta sin 2 alpha whole square. And to find the angle which this resultant of secondary force makes with the x-axis, let's say this angle is beta dash. So 10 will be sine upon cos. So the sine factor upon the cos factor. We place the values and we get the angle at which this resultant force is being applied. And if this 2 alpha is 90 degree, right, that means if the angle between these two bodies is 90 degrees, so alpha will be 45 degree, and we place the value of alpha as 45 degree. This is what we get, which is root 2 mr omega square upon n sine 2 theta. So in V engines, we already know that two connecting rods, they run a common crank shaft. So in the question, we are given that the cylinders of a V engine, they are set at 60-degree angle. That means the cylinders of both the engines, for both the pistons, they are at this angle is 60 degree, which is equal to 2 alpha, right? So alpha, that means the angle which they makes with the x-axis. So alpha is 30 degree. Now each connecting rod length is 600 mm. So this is 600 mm, and the crank radius, which is r, the common crank for both the systems, is 120 mm. Rotating mass is given, which is 2 kg, and the reciprocating mass is 1.2 kg per piston, right? Because there are two pistons, so for each piston the reciprocating mass is 1.2 kg, and a balance mass is fitted opposite to the crank, which is 2.2 kg at a radius of 150 mm. So we have to find the maximum and minimum primary and secondary forces if the engine is running at 800 rpm. So this is the system that we have. We have got the two cylinders, right? And the mass of both the cylinders is denoted by small m, which is 1.2 kg. They have a common crank and the mass is given as capital M, which is 2 kilogram. The length of both the connecting rods is small l and length of the crank is small r. And in the question it is given that to balance the unbalance produced because of the reciprocating and rotating masses, there is a counter mass which is being added opposite to the crank. So this is the counter mass and this mass is m dash at some radius r dash, which is already given in the question. So because these are the opposite angles, right? So if this angle is theta, this angle will also be theta, which the counter mass makes with the x-axis, right? So we know the values of L and R, so we can calculate N, which is L upon R. Speed is given 180 rpm, so we can calculate omega, which is 2 pi n upon 60. Now for the unbalanced forces, the equation for the force is mr omega square cos theta, where this is termed as the primary force, and mr omega square cos theta upon n, which is termed as the secondary force. And in the question we have to find the resultant, primary and the secondary forces. So firstly we'll talk about the forces along the x-axis, right? So the primary force along the x-axis because of both the connecting rods is 2 mr omega square cos square alpha cos theta. Now this we have already derived, right? And how we derived? We said that the primary force is mr omega square cos theta. Theta is the angle which the crank makes with the line of stroke. So in case of first cylinder, the angle which the crank makes with the line of stroke is theta minus alpha, which is theta minus 30 degree, and in second case it is theta plus alpha. So for both the forces, their x component will be the cos factor, right? Cos theta factor. So when we add the two factors, we get this equation, and we have already done the derivation in another video. Now along the x-axis, the another force that is acting is because of the rotating masses. This crank which is rotating, right, it is having a part of its centrifugal force along the x-axis. So what is the centrifugal force? It is m, capital M r omega square, and its component along the x-axis is mr omega square cos theta. The third one is the balance mass which we are using, which is m dash. So it is also rotating at some speed. So the component along the horizontal component is this force, right? So which is in the direction opposite to the direction of the centrifugal force produced because of the crank mass or the masses at the crank pin. So this is negative of m dash r dash omega square, and because the force is produced here mr omega square, so along the x-axis it will be cos theta. So the total unbalanced forces on x-axis will be sum of all the three forces. So we add them, we take all the common factors out, which is omega square cos theta, and we know all the values. We know alpha is 30 degree, capital M is given, which is 2 kilograms, small m is given, which is 1.2 kilogram, and m dash is 2.2 kilogram, r dash is 150 mm. So we place the values and this is what we get, and theta is unknown. We do not know the value of theta, right, that we have to calculate. So this is the unbalanced force along the x-axis. Similarly, we can calculate the unbalanced force along the z-axis, because whatever the unbalanced force because of the prime reciprocating mass, it is along the line of stroke. So its horizontal component is the cos theta and its vertical component will become the sine factor. So we get the value which is 2 mr omega square sine square alpha sine theta. Similarly for the crank, because the centrifugal force is in this direction, its z factor will be mr omega square sine theta, and for the counter mass it will be in opposite direction. So it will be minus mr omega square sine theta. So this will be subtracted, right? So we get the common. Now to get the resultant or the total force along the z-axis, what we do? We add all the three forces that we have calculated, the primary force and the centrifugal forces, right? So omega square sine theta is common. We take it out of the bracket and we place all the values, all the known values that we already know. So this is the total unbalanced force that we get along the z-axis, which is minus 217.8 sine theta Newton, because sine theta is the value that we have to calculate. So the resultant primary forces will be the resultant of the forces along the x-axis and the z-axis. So under root of this horizontal component plus the vertical component, it will give us the resultant, and this angle is the theta along which the resultant is acting, the beta along which the resultant is acting. So this is the value of the resultant primary force that we get. So the maximum force is generated, or the maximum force is produced when theta is 0 degree. So when we place cos 0, it is 1, and sine 0 is 0. So we get the maximum force, and when theta is 90 degree, we get the minimum force, which is 217.8 Newton. Now we have to also calculate the secondary forces. Now secondary forces are mr omega square cos 2 theta upon n. So using this equation, we can also find out the secondary forces because of the cylinder 1 along the line of stroke and cylinder 2 along the line of stroke. So once we get the values, we can find their components along the x-axis and the z-axis. So while finding their components along the x-axis, it becomes cos theta for both, cos alpha for both cylinder 1 and 2. So along the x-axis, secondary force is this, which is 2 mr omega square cos 2 alpha upon n and cos 2 theta. And along the y-axis, the force that we get is along this axis, right? Along the z-axis. So one will be in this direction and another one will be in the opposite direction. And because we know the values along the x-axis and the z-axis, we can find the resultant easily. You take all the common factors out, place all the known values. We know what is alpha, right? We know what is mass of the rotating parts, mass of the reciprocating parts, right? And we get this equation, and this gives us the maximum. Whether you place theta 0 degree or 90 degree, we find that the maximum and minimum secondary force, it remains the same. Now one thing to note here is that the centrifugal force effects because of the masses, it does not affect the secondary force, therefore it is not taken into consideration, because the rotating masses, they are because of the second harmonics of the piston acceleration, therefore their factors are not counted, and we are only taking the secondary force which is produced because of the unbalance of the reciprocating parts. And this equation also tells us that the value of the secondary force, it remains constant. The maximum and minimum value remains the same in the whole system. So V engines are basically the combinations of two connecting rods in such a way that two connecting rods, as a combined effort, they move a single crankshaft. And the cylinders, they are also inclined at certain angles. So in the question it is given that the axis, they are inclined at right angles to each other. That means if these are two cylinders with pistons, they are at an angle of 90 degree to each other. Now the weight of each piston is 2 kilogram. That means, let's say if the weight of each piston is small m, so small m is 2 kilogram, and the weight of connecting rod is given for both of them, it is 2.8 kilogram. The weight of the rotating parts is given as 1.8 kilogram. The length of connecting rod L is 400 mm, and its center of mass is given as 100 mm from the crank pin center. Stroke is given as 160 mm. So when the piston, it moves to and fro, or it does the reciprocating motion in a cylinder, the distance between its extreme positions is known as the stroke. The maximum distance It can move inside the cylinder. This distance is the stroke. So we have to show that the engine can be balanced by revolving and the primary forces because of the counter mass and the magnitude of center of mass from crankshaft and the value of resultant secondary force for the speed of 840 rpm. So we are already given the speed, which is 840 rpm. So omega becomes 2 pi n upon 60. It is 88 radian per second. Length of both the connecting rods is given L, that is 400 mm. Now from where we got this value of the R, which is the length of the crank or the radius of the crank. Now see, the piston stroke is given, which is 160 mm, right? So for the piston to move from one position, one extreme position to another extreme position, in that distance the crank, right, it rotates 180 degree. That means this is the diameter. So this 160 or the stroke of the cylinder is equal to the diameter of crank. So its radius become, so 1 is 60 upon 2, which is 80 mm. So n is what? L upon R, it is 5. Now we are given that the angle between both the cylinders of the system of the engine, they are at 90 degree. So we have already considered that the angle which they make with the x-axis is alpha. So 2 alpha for both of them. So alpha and alpha. So 2 alpha is 90 degree, alpha comes out to be 45 degree. Now we are already given that the center of mass of the connecting rod is at the distance of 100 mm from the crank pin center. So crank pin is at point A. So the center of mass is lying somewhere here at a distance of 100 mm, right, in both the cases. So whatever we do, it will be into 2. So can we distribute the mass at the point A or at the crank pin? It is 1 point A, which is the mass of the rotating parts, plus the part of the mass of the connecting rod which is lying at the crank pin, which is the total mass into this distance, which is 300 upon 400 into 2, because for both the systems this ratio is for one connecting rod, and because there are two connecting rods, so it becomes into 2, considering that there is only one crank pin. So the total mass becomes 6 kilogram. So what is the unbalanced force? It is mr omega square, which is 6r omega square. Now the total mass of the reciprocating parts is the connecting rod, which is 2 kilogram, plus the part of the mass that is lying at this shaft, at this piston. So it will be 2.8 into 100 upon 400, right? Because the other part of this is lying at the crank pin. So what they have done, we have actually dynamically equivalent reduction is being done for the connecting rod, which we have already studied. So we can say, or we can assume, that the connecting rod can be replaced by two point masses, one at the crank pin and one at the gudgeon pin, right? So the total reciprocating parts will be the 2, which is the mass of the reciprocating parts, plus the part of the connecting rod, which is 2.8 into 100, this distance, upon 400. So it comes out equal to 2.7 kilogram. So the resultant primary force will be is mr omega square along the crank. So because of this reciprocating parts, it is 2.7 r omega square. Now the total unbalanced forces is because of the revolving parts and the reciprocating parts, which is 8.7 r omega square. Now we are saying that to balance this 8.7 r omega square, we have to place a counter mass, let's say m dash, at some radius r, in such a way that both this counter mass balances all the unbalanced force. So m dash, r dash is already given, which is 100 into omega square is equal to 8.7 r omega square. Now the speed for both the systems will remain same, so it will cancel out, and we already know the radius for this crank is half of the stroke, which is 80, and we know the mass, so we can calculate what should be the counter mass added for the system. Now the second thing that we have to calculate is the resultant secondary force if the speed is 840 rpm, right? So we know the resultant secondary force is this root 2 mr omega square n into sine 2 theta. So we can calculate, we know what is theta, it is 90 degree. We know m, we know r, omega is already known, n is already known. So we place all the values and we get this answer, right? And to find the maximum value, so maximum is what? When 2 theta is 90 degree. So when we place the value, we get 473.1 Newton, right? So if the question would have asked what will be the secondary force in the system, we'll place theta directly in the system. But the question is saying the maximum value for the system. Therefore, okay, sorry, alpha is 90 degree, theta is not 90 degree. Therefore, we are getting the answer in terms of theta. And the system will give the maximum value when theta, that means the angle which the crank turns from the x-axis, right? It is theta. So when it is 90 degree, we'll get the maximum value of the secondary force.